is Advanced Math SBAC worksheet number 6. This one we are going to talk about numbers of solutions. Okay, so we will be adding notes here. Another thing is it talks about extraneous. Extraneous solutions are when you plug an apparent solution in and then it gives you some type of error or inconsistency when you plug that solution back in. So I'm going to write that down. Extraneous solutions are values you get from solving but give you an error or a false statement when you plug them back in. Okay, and those are created sometimes by our manipulations of equations when we go over the equal sign. Okay, those come out sometimes when you're doing those, like x squared. So like if I were to have something x squared equals 9 and you square root, okay, you get that absolute value, okay, and then you'd have your two equations. Whenever you get something like that, you want to check them. Another thing that you want to do is if you have a square root of something like x plus 3 equals an x plus 4, okay, you'd square both sides on this one, you'd get two answers, you'd have to plug them back in to see what works, and that's because square roots, you're not going to get imaginary numbers with negatives in there, okay. So this one would probably both work because it's a quadratic, but that one wouldn't. That one would most likely have an extraneous. So that comes up a lot with roots. The other type are with rationals, okay, and we'll talk about that as we work through here. Okay, so here, if I were to try to solve it, you want to stop and think. Okay, so I'm going to write that down. Okay, so that was root x equals -7. Always stop and think when you have logarithms, radicals, or rationals. Okay, square roots are never negative. So that's no real solution. Okay, here, this is a positive, so we could do something. Okay, x squared minus 5 equals 2. I'm going to square both sides. When I square both sides, I can sometimes do absolute value, but this is already implied to be a positive, I believe. Let's see. Hang on a second. No, it's implied that this whole difference is positive, so that can't be like a 0 or a 1 because that would give me a negative. So I'm going to go ahead and put that absolute value on there. Okay, then I would make my two equations. Okay, but if I add my 5 here, I get x squared equals 1. And here, if I add my 5, I get 9. Okay, when I square root, I get x equals plus or minus 1. I get x equals plus or minus 3, but I gotta plug them back in because it looks like I have 4 answers, and here it's saying only 2 real solutions. So let's plug those in to my original. So if I plug in a 1 here, 1 squared minus 5, whether it's positive or negative, it's going to be 1 minus 5. You guys can come in. Perfect. All right, awesome. Okay, so when I square that, I would get negative 4. And I can't square root a negative and get a positive 2. So this one I would get rid of. Okay? And that's because I can't have either one of those, because if I square negative 1, it won't work. Now my chances are that these could both work, and if I think about it, doesn't matter if it's a positive 3 or a negative 3, because negative 3 squared or positive 3 squared are both positive 9. Square root of 9 minus 5 is square root of 4, and square root of 4 does equal 2. So that one worked. But I have plus and minus, I have 2 answers there. Okay, the last one here, we are solving a rational equation. Okay, so I'm going to have 5 over x equals 2 over x plus 6. I'm going to cross multiply. Notice I distributed. I'm going to subtract 5x on both sides. And when I divide by negative 3, I get x equals negative 10. I'm going to plug it back in. That would be 5 over negative 10 equals 2 over negative 10 plus 6. This will give me negative 1/2. And that would be 2 over negative 4. That's a negative 1/2 is equal to a negative 1/2. So that is verified, but only one solution. Alrighty, let's see here. Getting close. Okay, here, if I subtract the 5, I would have square root of 3x equals negative 5. So I can't square root a negative. Here, if I cross multiply, I would have 36x equals 36x. That's identical on both sides. That's infinitely real. Let me add that comment down here. Infinitely many solutions occur, no E, when both sides of an equation are identical. Okay. Alrighty, so that one's infinitely many. Here, when I cross multiply, I get 3x plus 6 equals 5x. Okay, if I subtract my 3x, I get 6 equals 2x. When I divide by 2, I get x equals 3. That's one solution. Okay, here it's very similar to that other one. I'm going to show my work right here. X squared minus 7 equals 3. I square both sides. Okay, so I could do plus or minus on this. Okay, I don't know that I actually have to have the plus or minus, but when I check, I have a feeling I'm going to throw some answers out anyway. So I'm going to go ahead and do that. I'm going to have a 9 there. X squared minus 7 equals 9. X squared minus 7 equals negative 9. Could that be the case? Maybe, we'll see. Add 7, x squared equals 16. Add 7, x squared equals negative 2. So that one will not give me real solutions. Okay, if I square root here and here, I get x equals plus or minus 4. If I plug in a positive or if I plug in a negative, I'm going to get 16 both times. And 16 minus 7 is 9. When I square root, I get 3. So there's 2 real solutions. Okay, last one. We've done a few of these now. If I square both sides, I would get this. I would get here, but do I need the plus or minus? They made an error in step 2. Okay, only 3. I know that that's not going to be true, because if I plug in the 3 or the negative 3, those both work. I know that one's not going to work. Okay, so is the error made in step 2? I don't see anything wrong with this. It would be step 3 if that plus or minus is needed, but you notice whenever we use the negative one, it's not working. It's giving me false answers. So I'm going to say that this one is correct. Okay. A. Okay, that's it. Stay tuned for the next couple of videos.